Yeah, okay. So my name's Holmes Wilson. Most recently, the most recent significant role I had was as the co-founder of FightForTheFuture.org, which is a US-based civil society activism organization that works on activism for on policy that affects the internet. So it was very active on fighting censorship, site blocking rules in the United States, specifically SOPA and PIPA in 2011, 2012. We were really active working on tech policy reform or surveillance reform in the wake of the Snowden revelations, and also in passing net neutrality rules in the US and in the EU. So that's kind of the activist half of my work, but I've also worked on software projects. So in 2005, I was one of the co-founders of Miro, which was an early attempt to build a decentralized video distribution tool using BitTorrent, RSS, and a desktop video player. So the general theme in my work is that I do activism for the internet using the internet. And the two modes have been either activism using the internet to build campaigns. That's what I was doing at Fight for the Future. But also I've done activism where there's a social goal that I'm trying to achieve, some kind of change to the internet that I'm trying to bring, and the work is happening through software. And that's what Miro was, and that's what Quiet is. That's what I'm going to be talking about today. So, today I'm going to be talking about Quiet, which is, we were just talking about how there's an emerging constellation of projects like Berty and a sort of growing movement, and that all these projects are sort of cousins to each other in a way. So Quiet is a Berty cousin. It's an attempt to build an alternative to Slack and Discord, and perhaps someday to other team collaboration tools like Google Docs, Trello, etc., that does not require central servers, that is end-to-end encrypted, and that is local first, peer-to-peer free software. So just in terms of my motivations for building the project, I think a lot of these motivations will be familiar to many of you and shared by many of you, but I just sort of, so I hope it isn't boring, but I just want to like start there because I think that's what, that's sometimes the values behind these projects and the motivations behind them are really important, and it's fun to consider them. So my basic thesis is that the internet is amazing at enabling people to fight unaccountable power. And what I've seen in my life growing up with the internet is that every few years something comes along that just is some new breathtakingly surprising new instance of people taking it to some other level, coming together to fight unaccountable power. And it just keeps getting bigger and bigger. Like, in 2010, we had the Arab Spring, where governments are getting overthrown by popular movements on the internet. In 2016, in the US, we had a socialist candidate for president in the United States of America for the first time, making a viable campaign powered by the internet grassroots. Just as we were starting to think the internet sucked in 2017 and 2018, we saw the Hong Kong protests in 2019, which were, like a generation defending the future of their country from one of the most terrifying adversaries you could imagine in the modern world. And then in 2020, right in the middle of the COVID pandemic, we have the George Floyd protests in the US and solidarity protests around the world. So the internet's amazing at helping us fight unaccountable power, but at some point the feeling of the internet kind of shifted. Like in the 2000s and the early 2010s, the internet was just kind of, it was, just seemed awesome. But increasingly lately, it feels like the internet itself has become one more unaccountable power that we have to fight, right? And I think a big part of that is the dominance of a few tech companies, mostly American tech companies, Facebook, Apple, Amazon, Netflix, and Google, who are referred to in the business press as FANG, which is kind of a great name for them because it sounds like a cartoon villain. And I think who are symbolic of a larger class of a type of combination of business model and strategy that is all about centralizing power. So Quiet is an attempt to fix this by building a local first peer-to-peer alternative to a common type of product. And hopefully, and I think this is the aim of Berty too, sparking a movement of people to build more and more apps that work this way. So my take on why local first peer-to-peer is important here is that I think some people think that maybe regulating big tech will be enough. I disagree, and I think history shows otherwise. If you look at very regulated industries in the US and Europe, or most developed countries like banks or telecom, you don't see companies that are very friendly or very responsive to users' needs. You see companies that are, perhaps the regulation shaved off some of the worst abuses in some cases, but the companies are still extremely unaccountable and extremely powerful. So regulation isn't enough to hold tech companies accountable. And I don't think traditional activism will be enough either. We could get into this more, but I say this as somebody who's done a ton of activism, organizing people to fight companies, and the amount of entrenched power that a company like Apple has, where they have, they have a certain capacity in software and in hardware, and those things are interlocked. Or a company like Amazon with sophisticated infrastructure capacity, they can provide stuff that people need, and that gives them a huge amount of power. And it's difficult to take that on just by, trying to shame them into doing better. They remain unaccountable. Historically, I think the best way we've had to hold software makers accountable is free software, but free software has had a problem ever since the emergence of the cloud. And I can just get into that here a little bit. So problem with free software, the reason why it's not sufficient, I think, why free software or federated apps aren't sufficient for addressing this, or self-hosted apps aren't sufficient for addressing this, is that free software serves the entity running the software. That's the design of free software. It's designed to put the person running it in control. And so if you start there and look at how software is developed, first software ran in our computers, and we might have a word processor or a video player or a web browser or something like that. But increasingly, the most important apps we use are about the data we share with other people. And it's really hard to share data between people, between users of software without servers. So it's hard to do this in all of the software that's the most politically important software in the world, the software used for media, for collaboration, for working together, for basic coordination. All that software is sharing data between users. And most individual users do not own servers. It's just, there have been projects to get people to, install their own server in their houses, and some people do, but that has never really become a mass market thing, and you can see a million reasons why. So we have these points. Free software serves the interests of who's running it. It's hard to share data between users without servers. All the politically important software that we have is about sharing data between users. Most people don't own servers. If you put those things together, you see that there's a problem, because the free software solutions are not going to end up serving individual users. They're going to serve the entities running the software, i.e. the entities running the servers. For all of the important applications that require servers, because it's hard to share data between users without servers. So that's the kind of jam we're in. And to see an example of it, you have to look no further than Reddit, the front page of the internet. So Reddit, and not a lot of people know this, but Reddit was free software until fairly recently. And it totally didn't matter because Reddit was running the software. It was available in a repo somewhere, but Reddit was running the software. Users had no control over it because Reddit ran it. They could do whatever they wanted. They could kick someone off. They could, ban a sub. They could, change the way things worked. And the traditional power that free software gives users to fork was kind of meaningless in the case of Reddit, because forking Reddit would leave you with a big empty website. Right? Great, you forked Reddit, and now you're on your own in an empty website that, by the way, has an increasingly complex code base optimized for bajillions of users, and that's going to be very hard for you to keep up with. So in Reddit, you can see where this, as soon as we need servers, free software doesn't really solve the problem. So in terms of how we actually build local first peer-to-peer alternatives that challenge FANG or challenge centralized unaccountable power in tech, I think the first thing we have to do is prove it's practical. That's the necessary precondition. It's always been hard to build applications that share data between users without servers. We have to prove that now it's possible and that it's practical. And we have to rally others around that point. And yeah, the only way to do it is by doing it. We just have to prove that it works. And so that's why I care deeply about this. And And in terms of looking at different places where you could start, I mean, one really sort of appealing place to start might be to go right for the biggest thing and try to build a social network, right? Or try to build perhaps a search engine. And those are all really compelling use cases, definitely. But I think community chat is a really good place to start because first, it's a popular enough product type. It might not be as popular a product type as search or as social network, but it's popular. Discord is a really big deal. IRC was a really big deal for a really long time. It still is in some ways. And group chat is mission critical, so some people really, really care about it working well and having the privacy properties that they need and the censorship resistance properties they need. And it's also kind of cool because it's right at the border of private life and public life. So some team chats are very private, very specific to an organization, and some team chats are more like a public square. They're a bounded community, but they're sort of where we go to meet other people. And some of those communities can get quite large and very interesting and important things can happen there. So it's good to be where the action is. And finally, community chat is a great place to start. I'm sure anyone working on Berty appreciates this too, because chat is a lot easier to build local first apps for than other use cases like the broad social networking use case, or say Google Docs like collaborative editing, or search for that matter. There's things about community chat that sort of simplify some of the problems that you run into building these things. So I think it's a good place to start. So just to kind of quickly get into it, because I know people are coming from the Berty world and are quickly like, okay, this sounds a lot like Berty. Is it the same? Is it a competitor? What's the difference? And I think it's pretty distinct. So Berty, and someone should jump in and correct me if I'm wrong, but I sort of got into it or I did a round of like trying it out, and I'm on the beta and everything, or the alpha. So Berty seems more individually oriented, the way something like Signal or WhatsApp would be, where you sort of make your contacts first with them directly, I guess in some cases by scanning QR codes or sharing invite links, and then in order to build groups, you sort of invite your existing contacts into a group. And so it's very individually oriented, the way WhatsApp would be, Signal. Whereas in Quiet, it's more group oriented right from the get-go, the way Slack or Discord would be, where someone creates a community. You either create a community and invite people, or you get invited to a community, and then that's kind of how it works. There isn't any global network of users, or any global contact graph, or any global network that all the clients are joining, at least not yet. So now I want to just get into how it works quickly to give an overview. And actually, this is going to not quickly. I'm going to actually get into quite a bit of detail because I think these details are interesting, and I'm interested in people's questions and feedback on this stuff, and kind of sharing information and tactics between projects that, well, I think they're distinct, are pretty similar in the challenges they're facing. So yeah, the basic idea of how Quiet works is all data lives on local devices, not on servers. Data moves between those devices over Tor, only to devices that are within a defined community. So if you're in the equivalent of a Discord server or a Slack organization on Quiet, I'll call that community for the rest of the talk. If you're in a Quiet community, your devices are only connecting and moving data with other devices that are in that community. Admins add or remove community members, and that's how people would join, and that's the point of control. And when I say admins, I mean not the people making the software, but the person who has created a community, and of which there can be many. And in terms of the platforms we're targeting Mac, Windows, and Linux with an Electron app, and iOS and Android with a React Native app. And most of the code is in Node. And we use OrbitDB, and OrbitDB sits on top of IPFS. And then we sort of rip out all of the libp2p transports except for the WebSocket transport and hook that up so that it only connects out over Tor. And we ship a Tor binary with each client. So it's pretty much OrbitDB and IPFS over Tor is the basic networking stack. The Tor part's pretty interesting, and so I'll get into that a little bit. I like Tor a lot for peer-to-peer apps, for peer-to-peer local first apps. So with Tor, every peer is an onion address. So instead of like having a public IP address that can change, we just have one onion address. This is inspired by onion addresses. In case you're not familiar, are like if you've ever heard of the so-called darknet or something. The addresses are a cryptographic key followed by the suffix .onion, and that is it's a location and a DHT, I guess. No, it's a signing key that you use with the Tor network to find a rendezvous point in the Tor network or something, and then you would connect to that server through various layers of the Tor network. I think that explanation is right. Anyway, this approach of making peers in a chat app onion addresses is inspired by a project called Ricochet, which is pretty ingenious, where someone built a peer-to-peer chat app. It's not the project isn't active anymore, but it inspired a lot of other stuff. Someone built a peer-to-peer chat app where you can communicate with another user just by giving them your Tor onion address, and they give you their Tor onion address, and then you're both able to connect to each other's onion addresses and exchange messages the way you would submit data to a normal web service or to any service on the internet. And so Ricochet leaned on Tor for all of the hard parts, like traversing routers and funny local networks. Or it also leaned on Tor for end-to-end encryption. So the conversations were end-to-end encrypted with perfect forward secrecy thanks to Tor, and that didn't really have to get dealt with at the application layer. It's a cool way to do peer-to-peer. Anyway, so Quiet only reveals these onion addresses to known members. In the latest iteration of onion addresses, they're not guessable. They used to be guessable, but they're not guessable anymore, so you can't just like war dial onion addresses and find some peers. If you don't know the onion addresses of peers in the network, you will not be able to access the network. And Quiet only connects to onion addresses of people it knows. And so these three rules of each peer is an onion address, Quiet only reveals onion addresses to other known members, and you only connect to the onion addresses of members you know, that creates this nice wall around each community, which is important, because I think there is potentially this tension between peer-to-peer and privacy, where once you start building peer-to-peer apps, in order to just do the stuff they need to do to connect to connect to between clients, they end up leaking a lot of data to the network, or having to leak a lot of data to the network. And Tor really avoids that. Tor gives us a nice clean wall around each community. So if you're using something like Quiet for your company or your nonprofit organization or your newspaper, you know that to the extent Tor is reliable, there's this barrier around your team where that is adequately encrypted and it's difficult for others to get in without access. So yeah, these are all the reasons why Tor is awesome. Onion addresses are forever, which really simplifies peer discovery. It gives you end-to-end encryption and forward secrecy out of the box. You get pretty minimal metadata leakage. Tor does leak some metadata to attackers capable of traffic analysis, like your internet provider or military intelligence operations like the NSA or GCHQ. But it's pretty much as good as you can get right now, at least for metadata protection. There's some stuff on the horizon like mixnets that would be better, but it's pretty much what we've got. And the latency is pretty good. It's definitely good enough for chat. And yeah, it's an established battle-tested platform with very well understood strengths and weaknesses. So people kind of know what they're getting when you connect over Tor. And so quiet controls access by standard PKI. Each admin runs a sort of standard certificate authority and public key infrastructure. An admin gives an invitee an onion address, the way you'd give a Discord invite link to somebody joining your Discord. The invitee submits a certificate signing request to the admin signs it, the invitee syncs state from the admin, which gets all of the other certificates. That's just like connecting to the CRDT and syncing state, or connecting to OrbitDB and syncing state. And members can use their certificates to prove that they own their username, which is nice. Usernames are a thing that's very easy for centralized services to do and kind of hard for peer-to-peer services to do, but this gives us a nice way to do it. And admins can remove members by revoking certificates, and at that point, peers wouldn't be able to connect to the network anymore if their certificate was revoked. So we haven't implemented that yet, but that's how we're planning to do it anyway. And yeah, you can also we haven't done multiple device support, or multiple admins, but you can tackle both of those things. The problem gets a bit more interesting, but it's fairly straightforward. So in terms of message delivery, we use OrbitDB, which Berty uses too. That's for folks who aren't familiar, it's a CRDT. CRDTs are sort of like Git, where changes can be added and changes are then syncable between peers without losing anything. Every change is an immutable addition to a log. When a message gets sent, it's getting added to the user's local OrbitDB. That's getting gossiped to peers via IPFS pub sub. And I think the implementation's gossip sub. That goes through the sort of IPFS stack out through TOR to other peers, and then other peers see the message and add it to their own local own local OrbitDBs. One of the really important things in peer-to-peer chat is achieving the functionality that Slack and Discord achieve that IRC really never did achieve, of being able to quickly and easily and transparently fetch messages that were sent while you were away once you come back online. So that's the big reason to use a CRDT. And so, when someone comes back online, they connect to a few peers, they see that the peers are farther along in the tree than they are, and they sync messages that they have not seen yet. And there's this tension also where you want to, we choose to let all peers store all messages because it's the best way to achieve availability in case a message gets sent to a user who's not online. We want them to have the greatest possible chance of being able to fetch that message as soon as they come back online. And the best way to do that is to spread it around all peer devices. So file attachment is basically just like PFS. We haven't done it yet, but it seems pretty straightforward. Verifying sender identity, we have a standard PKI setup, so members have certificates, and the certificates are in the CRDT. Everyone syncs them. You can check that the certificates are valid. You can check that the username matches, that the username in the certificate is correct. And if you ever see that two usernames have been registered with different certificates, or the same username has been registered with different certificates, the app should show a warning in that case. Because it could be that your admin has been compromised, or that your admin who's able to issue these certificates is impersonating a user or something like that. And we don't want that to happen. So in terms of message encryption, it's pretty straightforward. We still share messages with every user, but we have a public key in the certificate for each user, so we encrypt a secret to that public key. Then the two users who want to DM each other have a shared secret. One of the sender creates an OrbitDB. They both put their messages in that OrbitDB encrypted shared secret. And the obvious drawback of that is that everyone on the network can see that those two users are communicating. Everyone in the community, that is, which is not desirable in a lot of cases. But you can achieve metadata protection by adding complexity. We're not doing that yet. That's a future iteration, but there's ways to do it, especially since we have TOR. You could imagine peers connecting to some random peer in the network via TOR, dumping messages anonymously, those messages getting added to a CRDT and synced by everybody else, but only readable to the recipients. So yeah, group chat's a little more complicated, but similar to DMs, you basically send secret pairwise to each person invited to a group chat. Still use a single Orbit DB for the group chat. This has the same problem with metadata, where everybody can see who's in the group chat and activity in this private group chat, even though they can't read the messages. And when I say everybody, I mean everybody in the team. But you can address that through the same mechanism that we talked about with DMs. And then then there's message deletion, which in the peer-to-peer context, I guess in any context, deletion is never really guaranteed. There's always an element of trust. Once you share data with someone else, like, it's impossible for them to prove that they deleted it. They could always take a picture of it or screenshot it or whatever. But it still matters enough to people's actual threat models, and we've done enough user research with teams facing sort of high-stakes threats that, and I myself have been in that situation of being in an organization that was facing high-stakes threats and hacking attempts, that deletion is really, really important. And even if you can't guarantee it, you want to make it work well and be possible. And we haven't implemented this yet, but the plan for deletion is that admins will be able to set time deletion for a community by sending a special message to all members. Users would be able to request that a specific message was deleted by sending a message to all members, and then nodes in the network would report back, or members would report back, that messages had been adequately deleted, or that they'd been deleted. And a pending state would show on any message where deletion was requested but not confirmed by all participants in the network. That's pretty much as good as we can get, and it's kind of a combination of just sort of figuring out the plumbing at the tech stack level, and then figuring out the UX for it and making sure that UX makes sense to people. So I think it's challenging but achievable. And finally, and this might be crazy, but I think while cryptocurrencies can't really solve all the problems that we face as local first app developers by any means, increasingly mainstream messaging apps are giving people ways to send money, and being able to send money between users in a community opens up a huge range of awesome use cases. And we have at least a couple of very private options for sending money using cryptocurrency. It seems kind of too good to pass up, and my team had done some previous research in this, so we kind of know how to do it and that it's doable. We're going to be using Zcash, which is a privacy-focused cryptocurrency. We're only going to sync the Zcash blockchain on user request, so that we're not just constantly burning resources and battery fetching Zcash transactions. We're going to use a standard Zcash light wallet, but with the difference that we'll send special messages within the quiet community, that is over IPFS, OrbitDB, and TOR, between users saying, hey, I just sent you money on Zcash. So they'll get a notification much faster than they would with a typical cryptocurrency or typical Zcash transaction, and they will then they'll be prompted to sync the Zcash network in order to actually receive the money. But that would be something that they trigger, which is good for performance and privacy reasons as well. And the plan is to connect to the Zcash light wallet server via Tor. We might not be able to do that right off the bat, but it will become possible soon. So that's pretty much it for the basics of how Quiet works right now. I would have liked to have had a demo for you all today, but maybe that could happen in a future meetup. We have a bunch of features in flight. We had a decent working demo of one community on Android and desktop, where messages where messages are sent with low latency and sync fairly well. But we're switching to the model where users kind of can create an arbitrary community, and there's a bunch of changes in flight that sort of messed everything up. making decent progress on iOS as well. We haven't figured out notifications on iOS yet, but we have the basic peer-to-peer stack with TOR running on iOS. So these are the kind of big, sort of weird, interesting problems that come up. That it might be fun to talk about now if others are working on Berty or considering these things in Berty. First is just CRT performance. Like, we're seeing some warning signs from OrbitDB, or it's either OrbitDB or IPFS, where it takes a long time for like 1,000 messages to come in, like minutes, I think, for 1,000 messages. And that's just seems unreasonably long and is not desirable. There's also some issues with PubSub and the DHT where peers are connected directly, everything works great. When they're not connected directly, we see a lot of latency, which doesn't make sense because or we see more latency than would make sense, at least. Yeah, there's some issues around multiple devices. Multiple devices seem straightforward, but there's maybe some UX issues around like what happens when you have a lot of lost or abandoned devices and you're trying to do stuff like deletion or just generally access control. Like, should devices get automatically removed after a certain amount of time inactive? Figuring out how multiple admins can have power and how they can invite people without like duplicating, for example, duplicating usernames or breaking some of the guarantees around username uniqueness. That's interesting. Stuff around message ordering that's I'm sure you're dealing with. That's like, CRDTs give you the guarantee that they prevent users from sending messages that appear to be in the future from when they were sent. They make that hard, but they don't really do anything to stop people from backdating messages, and that could be a security issue or just a UX issue if people are like maliciously sending messages that appear to be sent yesterday when they were sent just now. Yeah, there's some issues around just basic issue is when you don't have a server, how do you handle always-on availability? Like, if there's only one person on the team with the device online and they send a message, obviously that message goes to no one until someone else comes online at the same time as them. And I'm hoping that on Android we can keep a client alive most of the time, at least under some circumstances, enough that there's, in a small team, likely to be enough devices pretty much always on, that it works out, or that if we can't keep the device online all the time, we can connect to the network and sync at frequent enough intervals that we can guarantee a sort of continuous snapshotting and spreading of data across devices. But that's tricky. Yeah, that leads to this problem of notifications on mobile. How do you guarantee that? I know Berty is doing something like centralized push notifications, but with a twist. And just like peer discovery and this invite link approach we have depends on the admin being online, the inviter being online at the same time as the invitee for it to work. And that's not usually how a Discord invite link would work. Like, you get a Discord invite link, it doesn't really matter if the people who gave it to you are online. You just use it and join. And so a user wouldn't really expect to have to wait until the inviter was online in order to get in. And so we're looking for ways to avoid that. But they end up depending on creating some kind of discovery mechanism that exists outside the team, or you'd have to include all of the peer IDs or all of the peer addresses in the invite link, which would make it not a link anymore, or I think it would make it a huge amount of stuff that you'd have to send somebody, which could be bad UX. So yeah, these are the kinds of issues. There's also issues around removing people in large groups without having to redistribute key material to everybody. And there's some cool academic approaches to that, like message layer security, that are awesome, but that's sort of more complexity. And there's also the question of forward secrecy and post-compromise security, so that if people's keys get compromised, you're limiting how far back the attacker has access to messages and whether the attacker can kind of keep reading messages. So those are the sort of more kind of interesting problems on our radar. And don't know. I'm curious if people have questions or any thoughts on any of those interesting problems or other interesting problems that come up.
Yeah, just to let people know that if you have a question, you can write it in Meetup chat channel. You can write it, and we'll read it together. Yeah, just sounds really great. And I had a question. How many time did you work on Quiet from now?
Yeah, so we started in late 2018 with a or early 2019 with a prototype that was built on Zcash actually, where we used it was kind of a naive implementation that used the Zcash blockchain as a backend or as a peer-to-peer backend for sending and receiving messages, both individual messages and group chats. And it was cool for kind of exploring the space, but it wasn't. Ultimately, we quickly realized that we wouldn't get the performance properties that we needed, and so then we started looking more at Ricochet and TOR-based direct messaging, and then into CRDTs. I think about a year ago. I've been working on that approach since then. We started working on CRDTs around January, and yeah, messing with Orbit2B around January, February this year.
Okay, great.
Yeah, so Berty's ahead of us. Y'all have been in this space longer. At least y'all have been kind of on the fruitful path, I think, longer than we have.
Yeah, but it started 3 years ago. If am I wrong, Manfred? Maybe exactly the date I don't know, but I think 3 years ago. I think.
Yeah, approximately 3 years ago. Don't remember the exact day, but yes, it's basically the same kind of project with the same interesting problems. Basically, all the last points from your slides are exactly our current problems too. About the two last ones, we discussed with one of the co-authors of the MLS architecture, and basically, if you achieve to implement MLS in the P2P world, which is the biggest challenge, you should have automatically signal-like forward secrecy and post-compromise security. As soon as you use MLS, not only for just sharing, I don't know, the metadata, but also sharing all the keys, because MLS will give you a way to instantly invalidate any key, even from a compromised device. So yes, basically the last point should be automatically fixed as soon as you achieve the previous one. But when we discussed with the author from MLS, he clearly wasn't sure it's just possible in an asynchronous world to implement MLS.
So are you familiar with Martin? So Martin Kleppmann has a paper on this, I think, and I haven't read it yet, but yeah, I think Martin Kleppmann did a paper as a co-author on a paper on asynchronous MLS, and I don't think it came with an implementation, and that I think maybe is the challenge. It seems like the MLS implementations are all pretty early, and maybe like the Wire team is working on it, but yeah, I should send you. It'll be confusing to sort of bring it up here in the chat, but I can find it quickly. No, it's sort of buried, so I'll find it and send it to you. What about CRDT performance? I'm sure you're farther ahead on that than us, and I know that you're using the Go implementations of IPFS. Are you using Go, the standards for Go IPFS? We're using the JS side of things, and you also have your own implementation of Orbit2B in Go.
Yes, we use all the P2P code is exclusively developed in Go. So we have Java code, Swift code for the front ends, but technically the peer-to-peer code is always using Go on mobile, on desktop, on server, and whatever. In terms of performance, we have basically the same performance you said before. As soon as we use the real P2P world without any helper, any relays, etc. And since we're on the mobile world, we are working on optional relays to clearly improve the performance, especially the bootstrap performance when the mobile connects. To not wait for a few minutes, because on mobile it's not usual to run a program and wait for a long time. On desktop it's not a problem, but on mobile you clearly need to be very quick to bootstrap the node.
Yeah. You looked at we were looking at the OrbitDB snapshot functionality or something like it. Like what we felt like we wanted was something that could roll up the entire database or the entire state or some recent portion of the state, and then serve that to the user in one like send, instead of, or potentially from multiple sources, instead of the standard OrbitDB process of like having to kind of get some messages, look at the refs, fetch the refs, get those messages, fetch those refs, and that requires a lot of round trips. Have you looked at anything like that for improving performance, or are you mainly just thinking about relays and central servers?
We know that we will need to optimize this part too, but it can be done later, because as an opposition to your model of community, we can expect that you use Berty for very private discussion. So maybe we'll have less message to synchronize. So maybe the problem will just be discovered later for the users. And in terms of very naive idea, we think about using maybe per day OrbitDB, or per month, or making some kind of archives and only sync the archive of the last 100 message. We are not sure yet about what we can do, but for now the biggest issue is not about the amount of message. It's about the amount of conversation, and especially about the amount of dead conversation, which are taking today the same amount of performance like a real-time live conversation.
When you say, sorry, I'm missing the word you're using there. It's not about the amount of messages. It's about the amount of what?
Of conversation, of conversation to sync. So especially if you created a lot of conversation and the conversation are not used anymore, the node will still try to sync as many a lot of conversation, and it will basically take all the queue of network sockets, all the queue of CPU, to just check if a very old conversation is still active or has something new. And we clearly need to optimize the priority to quickly refresh the conversations that are recent, and periodically refresh the oldest one.
Wait, you're saying peer sessions?
Not necessarily peer session, more about looking for topics. So basically, looking if someone could have a new message for a topic, because we are not connecting to the peers we know that will have the messages. We are looking for someone who has the message. So basically, we are looking for the topics somewhere, even if the people is someone we don't know yet. As soon as we have the cryptography proof that he has a good message, we can sync the message, and then we can check for the next one. So basically, we can speak with someone that was invited after we disconnect to our phone for a lot of time, and continue the synchronization with a new device.
Got it. I think I follow. To me, this sounds like it's related to sending messages across a global graph of users on a global network, and you're doing something like, the messages are in a hash table, and you have to do lookups for each conversation or for each message, and that's time consuming. Is that what you're saying?
Yes, the problem is about looking for a lot of topics, because technically an OrbitDB is a topic, but a message is also a topic. So as soon as you have a lot of conversation, we are technically looking for maybe 2 or 3 times the amount of conversation, and especially on mobile, you cannot make a lot of lookups concurrently. So you need to have a queue. And this queue by default won't be ever optimized in terms of finding the good peer or finding the good topic. So yes, we have a lot of optimization to do, not necessarily on the topic size or BDB size or something like that, but more about looking for topics. And then, as soon as we have a good connection with someone with at least one message from the topic, we can just try to download as many messages as possible and just check each time if the message is a good next one. But yes, the biggest issue is about loading the app and letting the app trying to look for each topics if there is something new.
Yeah, makes sense. I think we haven't. Our problem is a bit simpler because in our loading sequence, it's load the app, connect to some peers, and set and get their heads. And once we get their heads, we immediately start getting messages that are relevant to us. And then it's just a question of how fast we can get all of them. That's the way it's looking for us now. And a related problem, a problem for us is like, what happens when the number of peers is very large and a large percentage of those are offline. So if you had a big community, in our case, if you have a big community without a lot of online peers, then we have a performance problem because you know all of the peers and they all have permanent onion addresses, but you're connecting to a lot of dead ones, and then then you get into a problem of making lots of concurrent connections and running into those limits. And TOR also becomes a problem, I think. TOR performance becomes a problem in that case. So that's a related problem that we have, but it's not so bad when the teams are small. And then when the teams are large, I think we could introduce a tracker or something and handle, try to make sure we aren't leaking metadata to the tracker. But the tracker would tell you for a given team ID, could be secret and only known by just members of that team. It would tell you the addresses of the peers, which could be encrypted to a secret known by the members of that team. That's a related thing for us. But, yeah.
And in our case, I'm not sure, but I think that we don't care about having a lot of people offline. What will make a huge difference is clearly the group size, but more because it will create a lot of noise in terms of metadata to share the new keys, to announce the new people, etc. But since we are looking for topics and we are just retrieving new messages from the one who has something new on my topic, we don't need to sync with everyone each time. The only time when we want to be synchronous and to be sure that we are talking to everyone is about clearly adding contacts. But as soon as we shared everything in terms of keys, etc., we can clearly add new people and discover. Clearly, we switch from peer-to-peer conversation to topic-based conversation, and topic-based can be about a conversation with thousands of people, and we only speak with one device because we have everything in terms of cryptography proof that the message relayed by the peer was written by the good person, and yes, we can sync everything. Know the next message, know the eventual new peers, know the key rotation, etc. So in our case, I don't think we have issue with offline devices. But as soon as you have a lot of people and they can add new devices, etc., yes, it will create a lot of noise in terms of metadata, and we can have a very huge database just for the invisible thing that makes the conversation working. And in our case, we have multiple orbit DBs for each conversation. For that reason, we have one just about the messages and one just about the metadata of who is here, what are the keys, etc.
Got it.
And we made this choice to be able to have different rules of retention, etc. So basically, it's possible to say, okay, the messages are always backed from everyone as soon as they join the conversation. So you won't synchronize the previous messages before you join, but you will start backing up and making available to anyone all the message coming after your join. But in terms of metadata, we have some metadata that is used for keys, and this RBDB is interesting in terms of what is the current state, not about being able to scroll the history of the changes.